I'm delighted to welcome a geologist this evening, an igneous petrologist, I love that term, to tell us more about the tourmalines and other treasures of the area. Myles Felch is a curator and the staff geologist at the Maine Mineral Gem Museum, that wonderful new museum in Bethel. He grew up in Union, Maine, and as a child, he too was fascinated by mica. But it wasn't until he got to college, University of Maine at Farmington, that he found his life's direction. And, some of us have done that. We've gone to college and then suddenly there's a dynamic teacher in an utterly engaging course, and that's it. And his utterly engaging course was an introduction to earth and environmental sciences. He had gone thinking he would be a dentist when he went to college. And I will not say that he moved from dental cavities to rock cavities. What I will say is that I want to quote something he said to me because I loved it. He said that studying geology illuminated the landscape around me. Illuminated the landscape around me. I love that. I think that tonight he may do some of that for us here in Western Maine. And of course, as he talks, if you have questions, jot them down in the chat or on a piece of paper. We will have questions and discussion after his talk finishes. Meanwhile, please mute your microphone for the talk and welcome Myles Felch. Myles?
All right, well, I'm hitting a bunch of buttons. Thank you, Joe, for that wonderful introduction. Let me try to get myself situated here. Okay. I'm going to just try to get rid of all these videos here. It's kind of a distraction on my end. Can everyone hear me all right?
Yeah.
Okay, great. Awesome. So yeah, again, thank you for that introduction, Joe. Am I able to advance? Okay, yeah. So if you do have questions, not on this first slide, but you'll see the subsequent slides are numbered. So you can actually jot down the number of the slide if there was something specific that you'd like to talk about here. And yeah, so again, yes, my name is Myles Felch. I'm a curator at the Maine Mineral Gem Museum. If you have not made it over, I really encourage you to do so. Tonight I'm going to be talking about tourmaline, obviously, and which was recognized actually as the state mineral in the early 1970s, around 1970 actually. And in 1820, gem tourmaline was actually first discovered in North America in Paris, Maine, at the Mount Mica quarry. So we have our roots in tourmaline here in the state. And so this lecture is actually serves to complement a temporary exhibit that's currently installed at the museum called Tourmaline Turns 200, because when we had the celebration for the state's bicentennial, we also were here. We were celebrating the first discovery of gem tourmaline in North America in 1820. I just want to point this out because I thought this was funny. A colleague of mine sent this along. You guys did a great job over at the Hobbs Library disseminating this talk to a bunch of local newspapers. I even saw it with Bangor Daily News, but you'll note that my friend said, just because you're a geologist doesn't mean you are a curator of gems and minerals. And I said, no, I'm a curator. I just want to point that out. I thought it was kind of funny. So yeah, today we're going to be covering quite a few things in the build up to tourmaline. But first we need to talk about the rocks that they come from, because tourmaline is actually not found in many different rock types. There's actually specific rock types, hard rock deposits, where you'll find tourmaline, and many of them exist here in Maine. The important ones that we're going to be talking about today, the deposits, are called pegmatites. And you're probably going to hear pegmatite more in this lecture than you're ever going to hear again in your life. But a pegmatite it's a type of igneous rock that forms from a melt. So that's what igneous rocks are. So when Joe said I was an igneous petrologist, I study rocks that cool and crystallize from a melt. If you think of Hawaii with lava on the surface, that molten material eventually cools and crystallizes to form a hard, solid rock, and that would be an igneous rock. And so I tried to gear this talk for a general audience, but I did put in some higher level concepts and things like that. Hopefully we'll invoke some questions and things like that at the end. So just a small fraction of Maine's pegmatites actually contain any gem quality material, and gem quality tourmaline, and gem quality material also that can include beryl or different types of quartz or something like that. Many of these pegmatites actually contain cavities or pockets, myrolitic cavities, which can host some of the gem crystals, though they don't always do that. So in the middle of this lecture, I'm actually going to show you what it's like to actually extract a tourmaline crystal from a pocket. And then towards the end, when we wrap up, I'll show you how tourmaline is used in the lapidary arts, which is the primary use for tourmaline. Okay. So in order to understand what a pegmatite is, we first need to talk about a more well-known rock, that is granite. And the reason I do this is because pegmatites in general have similar origins and also a similar mineralogy to granite. And more people know what granite is than pegmatite in most instances. So this is going to be a little interesting here. We're going to get down to the basics. And so for anyone who's new to geology, I have this simple little crash course about what rocks are, okay? In the past, I usually reserve this for grade schools, but I find it works well even for adults. So I really like to introduce rocks in the simplest terms, often food related analogies. Those are always good. So we think of rocks as being like salad, right? So we have this salad, it's made up of a series of vegetables. I guess technically a tomato is a fruit, but you have some fruits and vegetables. And if we think of these fruits and vegetables individually as minerals, together we combine them together to make a salad, or we combine them together to make a rock. So a rock is made up of a combination of minerals. And there's many different vegetables out there, so you can have many different types of salads. You can also have many different types of rocks because there's many different types of minerals. And when you start combining different minerals together, you form different rocks, okay? So let's now apply this rocks or salad concept to this this slab of granite we see here. You'll note that this slab of granite is actually from Deer Isle, Maine. It has some pink grains, some white grains. Can folks see my cursor moving about? Anyone could just chime in.
Yes.
Yes. Okay, great. Thank you. Just want to make sure that that is being seen. So it has some gray portions here, and then there's also some black flakes. Okay, so this granite, just by using color alone, we can see that there's different minerals in this slab of granite. There's feldspar, one type of feldspar called microcline, or potassium feldspar. We just wanted to be broad here. There's white feldspar plagioclase, a sodium-rich variety. It could also contain calcium as well, but there's the gray portion is quartz, and then of course there's the dark flecks, that's biotite mica in this case. So the most important ones in terms of granite are the feldspars and the quartz. It's these three minerals that make up the highest proportion of granite. And you don't need biotite in the granite, you don't need muscovite in the granite, though you can have it there. You can also have garnet, or you could have tourmaline, you can also have amphiboles and things like that, but they're not essential. What's essential are the feldspars and the quartz. Okay, and it's these minerals, the feldspars and the quartz, that make up the majority of pegmatites. Not all pegmatites, but most pegmatites, when we say the word pegmatite, we're referring to one that is of granitic composition. Though they can have other compositions as well. But for our case, what we're talking about, when we're talking about Maine pegmatites, we're talking about granite pegmatites. So feldspars and quartz. And so if the mineralogy of pegmatites and granite is similar for our purposes, what really makes them different from one another, right? So what is a pegmatite? So we think about that image of the granite slab on the last slide. There were hundreds of small grains there, lots of little red grains, lots of little white grains, lots of little black flakes. Well, instead of making lots of little mineral grains, instead we take all of those red potassium feldspar grains and we make one grain out of it, or a couple really large ones. Okay, so a pegmatite in the simplest terms is a very coarse-grained igneous rock that commonly has a similar composition to granite. And when I say coarse, I mean the grain sizes, the individual mineral grain sizes are about an inch or more in size. In some instances, the crystals can reach up to 30 more feet in length, so they can get really massive. So, but again, these are igneous rocks, like granite. They have cooled and crystallized from a melt. And importantly, this process happens below the surface. Many times it's 5 miles or more below the surface where these pegmatites form. All in all, in terms of like what these intrusions look like, is they're commonly flattened planar features, like we see on the image to the left here. They're kind of white streaks that will cross cut some other type of rock. Or here's an image on the right where we have this one kind of diagonally oriented with the yellow line showing that, and it's actually cross cutting a granite. And if we got up really close, we'd see that the grains, especially in this image to the right, in the pegmatite are much larger. Some of them are exceeding 10 centimeters or more, whereas, if we look at some of the grains in the adjacent granite, they're quite fine and quite small. So in the pegmatites in these images here are, no more than 1 to 4 feet in width. But if we were to go to a place like Australia, some of the pegmatites there are about a mile or sometimes a little bit more in width. Okay, so they can get quite large. Okay, this image really is just to simply show how large minerals can get in pegmatites. So here's a view of a quarry wall at the Bumpus Quarry, which is really, it's in Albany, Maine. It's located only about 15 minutes south of the museum here in Bethel. And the image has been falsely colored this pale blue just to highlight the series of very large beryl crystals that were found there. There were several finds of large beryl crystals at this location. One of the crystals in particular was about 30 feet in length and 6 feet in width on one side, and they were the largest known of their kind at that time in the world. So that record has been beaten since then. That was in the early 1900s. If you wanted to see what one of them kind of looks like, you could actually come down to the Maine Mineral Gem Museum, and in the porch in the back entrance, there's actually one crystal section from one of these finds of large beryl. It's a specimen that's on loan from the American Museum of Natural History. So you could come and actually see, just to get an idea of how big these pegmatite mineral grains are. So that's one mineral grain right there. And that's, for those of you who are in the know, that's Frank Parham, probably the most prolific and well-known pegmatite miner here in Western Maine. Okay, so in all, there's well over, there are thousands and thousands of pegmatites found throughout Maine. You commonly can see them along coastal outcrops, like here is in the top right image here. We have an oblique aerial image that's just west of Reed State Park, and you'll see this dark rock on the coast. That's some metamorphic rock, and then you have these white streaks. It's almost like sand, but these white streaks that are cross-cutting, and there's the pegmatites right there. So even though we have pegmatites located throughout the state, there's really there's a belt of pegmatite deposits that extend from coastal, like Georgetown area, not far actually from where this photo in the top right has been taken. But they extend from Saginaw County up into Androscoggin and then Oxford County. And you see on this map, I've picked out, even though there's thousands, this map I could fill up, but it's these blue dots right here. These are some of the more productive, what I would call productive granitic pegmatite quarries. So historically, they were mined for feldspar or mica. And later, and even to this day, some of them are still mined for mineral specimens as well as gem material. The most well-known gem tourmaline deposits occur in Oxford County and Androscoggin. However, there is one location down in Georgetown, actually it's called the Georgetown Quarry, or the Consolidated Quarries, where gem tourmaline has been found there, but it's not very common in the coastal Maine pegmatites. And so, as I think I may have alluded to this, that not all pegmatites contain tourmaline or gem minerals for that matter. In fact, there's really only a very small percentage of all the pegmatites found in Maine that contain any gem material. and that includes Tourmaline. However, there's a more common and much less valuable species of tourmaline. We'll get into what species are in a minute, called schorl. And this is found in many of Maine's pegmatites as well as some of the granites. Okay. So you might have been looking at this map on the left and you might have asked yourself, well, why are all the what I've called productive or gem and specimen mines, those gem pegmatites, why are they located in the southwestern part of the state? Why don't we have any in the northern or the eastern part? And so let's take a look on the right at this map that's been produced by the Maine Geological Survey right here. And so by looking at this, you'll see that this map really highlights two things. It's the distribution of metamorphic rocks as well as igneous rocks like granites and things like that throughout the state. So the metamorphic rocks are highlighted as this kind of tan color into kind of a gross green to yellow, orange, and red. These are all metamorphic rocks, and you'd note that the majority of the state is comprised of metamorphic rocks. The gray kind of amorphous shaped things, these blobs are actually intrusive igneous rocks. So that could be granites, it could be gabbros, it could be anything like that. And these are located sporadically throughout the state, though you'd note that there are certain zones where you see these, or certain regional patterns where you see these kind of coming out more than others. So by looking though at this, so not only does the map show us that there's a lot of metamorphic rocks in the state, but it also shows us that there are certain areas of the state where the metamorphic rocks are of what we call higher metamorphic grade. So they've experienced much higher temperatures and pressures than some of the other areas of the state. And so as we go in the north, these rocks have produced or have experienced much lower temperatures and pressures, whereas the rocks in the southern part of the state have experienced much higher temperatures and pressures. And so if we compare that to what we're seeing, what we see on the left here with this map on the left that shows the location of some of the more productive pegmatite quarries, we start to see a pattern uncover here. Okay, so it seems to be that the rocks that have experienced high metamorphic grade, so higher temperatures and pressures that are currently exposed at the surface, this is the place where these productive pegmatites tend to kind of crop out. So we tend to see them located in this area. So remember though, I said that there are thousands of pegmatites that could be plotted throughout the state, but it tends to be these ones that are tourmaline bearing, or at least they were mined for feldspar and mica, among other things. And the well-known quarries, it's in the southwestern part of the state, right around the area where we have high-grade metamorphic rocks. Okay, so, but before I get into why gem tourmaline is found in Maine, let's look at the distribution of some other gem tourmaline deposits that are found around the world. Okay, and there are a lot more than what I have listed here, I should note. Okay, but just some other examples from San Diego, California. This one's titled the Candelabra. It's been called the Candelabra for obvious reasons. Minas Gerais down in Brazil. Let's see what we have next. Elba, Italy. We have the Transbaikalia region in Russia, and of course the Himalayas. And there's a lot better examples out there than this one, the one I have photographed here. But this just kind of gives you an idea of the location of some of these deposits. 1 second. But the point I want to make here is that these gem tourmaline deposits are not distributed evenly across the globe. So in fact, they're really restricted to areas that have experienced some type of, or they have experienced a specific tectonic process over the course of geologic time. And so exactly do these worldwide Elbaite localities, and this is Maine as well, what do they all have in common? So these regions have all experienced a mountain building event, or what we call an orogeny. So I'll quickly summarize this. This is probably the most technical portion of the talk, but I'll quickly summarize what an orogeny is, or mountain building event, because it's a combination of geologic processes that are at play at the same time, or they overlap in sequence. So a mountain building event really occurs when we have two tectonic plates that collide, they converge on one another, and the collision of these two plates causes uplift in the crust. There's a lot of deformation in the form of folding rocks and faulting rocks. There's also many separate phases of metamorphism and plutonism where you're forming igneous rocks. So a mountain building event has all of these different geologic processes happening at once or in tandem or close to one another. But for our purposes, the most important process of all these is melt formation. And there's a few ways to make melts, but the fact that we're making melts during or after a mountain building event is crucial, okay? So in the most basic sense, it's a mountain building event that creates this situation where gem tourmaline bearing pegmatites can form. So it takes the right tectonic situation, the presence of the right precursor rocks, the convergence of two plates to force the rocks to depths where then they can be heated up to high enough temperatures to begin melting. And then of course you need to generally just uplift the region because again, these gem bearing pegmatites are forming 5 or more miles below the surface. So in order to get them to the top, you need to uplift the region, and continual erosion will scrape away the rocks up above, exposing the roots of a mountain belt. And in some cases that would expose some of these gem bearing tourmaline deposits. Okay. So really that in a nutshell, and we can take more questions towards the end if there are more about this. In a nutshell, that's why we have gem bearing pegmatites in Maine. We're part of the Appalachian mountain belt. So there was a mountain building event. Actually, there were several that built the Appalachian Mountains. And in different phases of those mountain building events, the right situation happened where you could produce gem bearing pegmatites, gem tourmaline bearing pegmatites. Okay. So let's move on and talk a little bit more about some of the minerals that we find in Maine's pegmatites. So some pegmatites in Maine can host more than 100 mineral species, which is a lot, and that's in a single deposit. But that's really not why they were originally exploited. The most important mineral was this one on the top right here, feldspar. So this was a mineral that was originally, this is why many of the pegmatite quarries in Oxford and Androscoggin County and also coastal Maine, Saginaw counties were open. And so they were exploited for this mineral, where it was ground up and used in the porcelain and ceramic industry. It's also used as an abrasive. To a lesser extent, muscovite mica was mined in Maine as well, but it was not as common as, say, in New Hampshire, where the mica was a much superior quality. Garnet is an accessory mineral phase, meaning it's just the majority of the pegmatite is made up of, again, like the composition of granite, feldspar, and quartz. There is, of course, some muscovite mica or mica. There's can be biotite micas or lepidolite micas, but they're accessories. They're just an additional phase. They're not the majority of the mineral that you find, the minerals that you'll find in that deposit. But garnet is commonly found in Maine's pegmatites, though its economic potential is extremely low, if that, at best. But those are kind of what I've called the not so glamorous, but here are the glamorous ones. And this is what makes Maine's pegmatites so interesting, is that the many other minerals that are hosted in these deposits at times. So many rare minerals and gem quality crystals are actually still being mined today from pegmatite deposits in Maine. Some examples of these would be like topaz here in the bottom left from Topsom, the Fisher Quarry in Topsom. We have beautiful purple fluoroapatite, particularly coming from this location here, the Pulsifer Quarry in Auburn at Mount Apatite. But there's different shades of purple apatites, blue apatites, etc., that are in a number of other pegmatites. We have a bunch of few varieties of quartz that are recovered from pegmatites in Maine. Amethyst, the purple variety of quartz. There's also rose quartz, a kind of pinkish variety of quartz. Smoky quartz, of course, kind of a dark gray to chocolatey brown colored quartz. There's a few different varieties of beryl that are also found in Maine. Morganite, the pink variety, and there's also aquamarine, the blue beryl, blue variety of beryl. So not any one pegmatite is actually likely to contain any or even all, all of these or even any of these minerals. It's really only a very, very small percentage of them of Maine's pegmatites produce any high quality mineral specimens. Okay. But when it comes to pegmatite minerals in Maine, really none is more sought after than the Maine state mineral, and that's tourmaline. And tourmaline is actually a whole group of minerals that includes over 30 different species. And it's really all thanks to this mineral formula, pretty complicated mineral formula that you see here. And go on to it. So tourmaline, like all minerals, has a chemical formula. This recipe of elements it's part of what makes each mineral unique from others, among other diagnostic properties. And so for tourmaline, the potential chemistries are quite variable. So there can be many different substitutions in different parts of the crystal structure. So different elements can substitute in different parts of this, different sites of this formula. And that in a nutshell is really how we can get over 30 different species of tourmaline. So, but what species are found in Maine? There are more than 3, but it's really these big 3. These are the important ones to know. So dravite, it's commonly found in some metamorphic rocks that are oftentimes associated with pegmatites, though not always. It's also found in some volcanic rocks in coastal Maine associated with volcanogenic massive sulfide deposits like in Blue Hill. And the important point here with dravite is that it contains magnesium. So it's a magnesium dominant tourmaline. Schorl, Schorl is the most common tourmaline species found in Maine. So it occurs in granitic pegmatites and even in some granites and metamorphic rocks. And the important point here is that this one contains iron. Okay, it's an iron dominant variety. Excuse me, an iron dominant species. But it's elbaite down here at the bottom. This is the most sought after species of tourmaline in the state. It's the only gem species found in Maine, actually. And the important difference chemically with this compared to the others is that it contains the element lithium, which some of you may be privy to lithium. It's been talked about quite a bit recently in the news regarding Maine pegmatites, lithium deposits in Maine. But it's this element right here. It's only abundant enough in pegmatite melts, so you're only going to see elbaite forming in granitic pegmatites. So only certain species of tourmaline are going to be found in certain types of rocks, and elbaite is one of these. It's only going to be found in a granitic pegmatite that's highly evolved and contains lithium. Okay, so here we have some examples of the other tourmaline species in Maine that we started with. Schorl, dark tourmaline, there's a garnet on the side there, but and dravite kind of bladed here in this instance. And so both of these are quite brittle, they're dark, they really have no value except as mineral specimens. Like the one on the right would be, valued as a mineral specimen and sold accordingly, but you certainly can't cut any gemstones from it. So it's just kind of the way it is with Schorl and dravite, and that's the last time we're going to talk about them tonight. So elbaite is the only tourmaline species found in Maine that's of gem quality, as I said before. It also happens to be the most common gem tourmaline species in the world. There are other species of tourmaline that can be of gem quality, but it's elbaite that's the most common. In Maine, green and red are the most common elbaite colors, though there are blue and colorless varieties. And it's well-formed gemmy crystals like this one pictured right here on the slide here on the right. They're found and recovered from these features that occur only in some granitic pegmatites, and that's what these features are called pockets. So we'll talk about pockets here. So I'll give you a broad overview of what a pocket is, or we call them, a geologist might call it a myrolitic cavity, but most people just call them pockets. And it's within these cavities that gem crystals can be found. Okay, and so these are actually literally holes in solid rocks. You'll see my colleague here digging in a cavity where he was digging out some amethyst. And there's an illustration right here on the left of, this is actually from a pocket from some Colorado pegmatites But the same concept applies, is that you have a void, an open space in this solid rock. And you'll note that in this illustration, these well-formed crystals can occur. So you can find really well-formed crystals within pockets. Sometimes you can find well-behaved dogs. This is for those of you making sure you're all still paying attention. This is actually the Havey Corey, the mine owner there, loves Boston Terriers. But anyway, and I just go back to this one right quick. This is a pocket from in Greenwood at the Hayes Quarry, and you'll note there's a ladder for scale. I don't have the full dimensions off the top of my head here, but it exceeded 30 feet in length in one direction. So it was a very, very large pocket. And if my memory serves me right, it was much longer than 30 feet. But again, I don't have the numbers in front of me. So it's these pockets. These features are really treasured by miners. They have the potential to give the largest return on investment because they can oftentimes contain an abundance of gem materials. That being either beryl or some type of quartz, or if all goes well, tourmaline. And so, but the thing is that these pegmatites are only found in these pockets, excuse me, are only found in a very, very small proportion of Maine's pegmatites. Many of these are the most well-known quarries in Maine: Mount Micah, the Havey, the Dunton Quarry, Mount Appetite quarries, etc. But yeah, in here, that's where you find these well-formed crystals. Okay. And so just a little bit of a background on what, how these things form. So these open voids form during the final stages of crystallization of a pegmatitic melt. And so at a certain point during the crystallization process, water actually exalves. There's an abundance of water, among other things, in these melts, and it exalves from a more silica-rich melt. And this is similar to, if we think of this like oil and vinegar. So water and the silicate melt will separate out from one another like oil and vinegar will, if left alone. So it's like a lava lamp. You have these pockets or bubbles of water or liquid that start to exsolve and form in the central portions of these pegmatites. And it's within here these crystals can really grow. Crystals can grow unencumbered into that solution. And so that's how you get these sharp, well-formed crystals. Some pegmatites contain many pockets, others contain less. Sometimes the pockets are grouped near one another, like they're closely grouped. Other times they're quite far apart. The size of pockets can vary from nickel-sized to areas probably as large as some of the rooms that you're sitting in. They can be quite massive, some of these rooms. So those of you interested, I would recommend checking out the chamber pegmatites in Ukraine for an example of some really large cavities in solid pegmatitic rock. What's interesting is that the contents of each pocket may vary from cavity to cavity. So if you have two pockets that are close to one another, it's not likely that you'll find the same material. There's going to be some variation. So for example, you might find two tourmaline pockets close to one another, but the color of tourmaline may be from each pocket. If you compare them, the color might be slightly different shades of green, or you might have more blue in one and then more green and maybe some reds in another. Also, the overall habit or the crystal form may be different from one pocket to the next. And you might also find different mineral associations in each pocket compared from one to the next. You might find phosphate minerals in one, you might find beryl in another, or so on. So they're very interesting little microenvironments within these rocks. But in some cases, like this image here on the left, you find that the pockets are surrounded by really colorful minerals, like brightly orange colored feldspars. There's purple lepidolite. You'll oftentimes see elbaite, elbaite, green tourmaline, and sometimes some schorl and things like that. And when you start to see these colors in the quarry, that can be a really helpful indicator that you're coming on to a pocket. So miners will use certain characteristics seen in the mineralogy of these rocks to kind of help them or guide them along their pursuit of these cavities. Okay, but sometimes pockets are not so hospitable to tourmaline and other minerals. So during the final stages of crystallization inside of a pocket, that final liquid phase can be quite corrosive, caustic, and sometimes it can actually partially dissolve pre-existing minerals, and that's because you get a buildup of volatile compounds at the end of this crystallization process, and the solution will actually eat away at the surface of a crystal and create this what we call an etched pattern here. And so there's some interesting geometric forms that occur because of this etching, and that's dependent on the orientation with the long axis of the tourmaline in this case. And so you'd see there's kind of this rectangular etched pattern on the prism faces. That's the long axis here, and on the top and the termination, you see these kind of triangular pits that form on the termination there. Whereas in this case on the right, and this is the same quarry, these are both from Mount Marie in Paris, Maine. And I should note that all of the images that I'm showing here are specimens from the museum and are likely displayed in the museum currently, unless I've otherwise noted in the slides if it was from some other location. Just point that out now. So yeah, we have one that's etched and one that's unetched, both from the same quarry and from nearby pockets. So it just goes to show you the final stages, the chemistry can vary quite a bit and you get a different result, which is very interesting. Okay, so now let's do the whole pocket experience, and we're going to go to the Havey quarry and see what it's like to discover a tourmaline crystal in a pocket. And so yeah, here's the Havey quarry and maybe some of the earlier stages of recent developments here. Though it looks much different now. Okay, so here we are in the backside of a pocket. So we're looking in, and we'll note that there's some quartz up against the wall. There's some orangish feldspar. There's lots of lapidolite. It's kind of granular and mixed with this white kaolin clay, the breakdown product of some of the more the feldspars that are more susceptible to corrosion. And then you see these elongated dark mineral grain, dark green grains. And those are the tourmaline crystals. And so you might carefully wash it out, or sometimes they use tools like a screwdriver or a pick to kind of, I've even seen chopsticks being used to poke at the clay to kind of get dislodge a crystal. And you take it off, clean it up. Oh yeah, happy miner. So this is Jeff Morrison, the owner of the Havey quarry here, holding up what is now called the Pocket Fairy. And if you remember that image, I had a Frank Parham. That is a name that has been given to Frank Parham because he has the uncanny ability. It's almost like a superhuman ability to show up whenever these miners are uncovering a pocket, and he gets, you know, to his first hand in there. And so they named that crystal after him. So there it is, the Pocket Fairy. And this one's actually on display at the museum currently. So as we saw with some of the tourmalines from Maine, as well as other worldwide localities, they come in a wide range of colors. Okay, but what exactly causes that color, the color in tourmaline? So color in minerals is influenced by several factors, or can be influenced by several factors. Chemistry, in the form of elements, the presence of trace amounts of elements. There can be structural defects, excuse me. Even some inclusions of other minerals can cause color. The elements that are responsible for color, we call them chromophores, we call those chromophores. And so color in tourmaline is primarily caused by the presence or absence of specific chromophores in trace amounts. In Maine, the most common colors of tourmaline are black, blue, green, red. And so it's the black and the blue and the green. These are caused by decreasing amounts of iron. So you see highest iron content, you're gonna have black, but as you begin to decrease, it'll be blue and then into greens. And there's different shades, of course, depending on the total amount, trace amount of iron there. If you are lacking iron, you have manganese around, that may give you a red or kind of pinkish color. It can also produce yellow in some instances, depending on the oxidation state of the manganese. And so it's, again, these subtle variations of the amounts of, in particular, these two elements, iron and manganese in Maine tourmaline, that's going to create a range of greens and reds that we see. So it's variations in chemistry that cause the color. So you note at the top image right here on the left, there's a tourmaline cross section, and that's we take a tourmaline crystal and we slice it perpendicular to that long axis, and that is something that we might get. We don't always get that, but you see this this tourmaline in this case right here from Georgetown, Maine. It's exhibiting this color phenomenon called this zoning phenomenon, where the separate domains within this crystal, they illustrate different stages of the formation of this crystal. And so it's kind of like rings in a tree. So the changes in color, they indicate a change in the fluid chemistry as the mineral is crystallizing. So in this case, we see in the center, as this would have been growing from the center outwards and from the bottom up, but in the center outwards, starts off iron dominant, and then the iron tapers off, and you end up with more manganese at another point. You get pinks, and then you get the yellows as well. So there's a progression of you see some higher concentrations of certain trace amounts of iron at first, and then they decrease over time. So it's a pretty interesting. The chemistry is pretty interesting there. So we have a special example of color zoning in Maine tourmaline called watermelon tourmaline. Maybe some of you have heard of this. And what's interesting is, though it's a term that's used worldwide, because tourmaline, in this case, the watermelon, obviously it mimics the appearance of the fruit there. The term is actually reportedly first used in Maine to describe some of the tourmalines coming out of the local pegmatites. It was coined by George Howe of Norway, Maine. So again, it's an internationally used term, but it was used first here in Maine based on some of the minerals that were coming out. So it's in this example right here, we see twice there's a very pronounced change in chemistry. First, in the center portion of this crystal on the left, as it was growing, this lack of iron, manganese was around, so that's what went in. And then all of a sudden manganese decreased, or there was a later, maybe the melt was contaminated or something like that. You had iron in the end, and so you have this green rind that grew around. So the chemistry of the fluid changed. Okay, and so by now, throughout this lecture, you've probably noticed that tourmaline can be quite transparent, which makes it a real suitable gem material. In fact, I think I've already shown some pictures of gemstones, but tourmaline is primarily used as a gem material. Okay, so gem materials have historically been divided up into two groups, precious and semi-precious, though these terms are kind of antiquated. But they do speak, I would say, to the overall rarity of the gem materials. So those that are precious, the big four well-known ones, that being diamond, ruby, emerald, sapphire, these come from deposits that are generally quite rare. And then it's even rarer to find material, or there's very small quantities of material that can be used to cut gemstones once you have that deposit. But I'll note that none of these, emerald, sapphire, ruby, diamond, none of these exist in Maine, at least not in any high quality. I have heard of one instance of a sapphire occurring in Maine, so but that's the only instance I heard in a very strange rock. But anyway, I digress. But all of Maine's gem materials, they fall under what would be called the semi-precious gem category. And so not only do these include tourmaline, but it's varieties of quartz and beryl as well. So chemically speaking, as we learned at the beginning of this lecture, there's 30 species of tourmaline known to exist, over 30 species of tourmaline known to exist. But when it comes to gem materials, we can group tourmaline by the colors that it comes in, and we can do this with other minerals as well, but we call these varietal names. So when it comes down to the chemistry, and if we're geologists talking about minerals, we would talk about the species of tourmaline that are found. But if we wanted to pick elbaite as that one species of tourmaline and talk about the gem varieties of elbaite, we could also do that. And it's just a different set of names that you know, gemologists use to describe the color. Okay, so as an example for tourmaline, varietal names, green would be verdilite, blue is indicolite, red is rubellite, colorless varieties are acrolite. And the same can be said for amethyst, which is a varietal name of, excuse me, same can be said for quartz, where you have the different varieties. Amethyst, the purple variety. You have the rose quartz, smoky, citrine, etc. And for beryl, there are varieties as well. Aquamarine, the blue variety, helidor, yellow. You can have colorless goshenite, etc. As I said way at the beginning, gem tourmaline was first discovered over 200 years ago at Mount Mica in Paris, Maine. And since then, there have been numerous discoveries that have yielded large quantities of the material, but a lot of it has been faceted into gemstones. So, but before a mineral can be cut into a gemstone, before it becomes a gemstone, it needs to be cut on a faceting machine. And so really, put simply, this is just a protractor with an arm attachment that holds a gemstone over some type of grinding wheel, whether it's there's a slurry of material on a plate, or you put on plates and remove them as you change the grit sizes. It doesn't matter. But this wheel spins, and you just kind of press the gemstone into it along the wheel, and making sure that the grinding surface, the grit that you're using is harder than the mineral you're trying to cut. And yeah, you cut it based on a series of angles. And so if we look at the top right image here, you see the kind of the anatomy of a gemstone. We have all of these different flat faces. These are all facets, but there's different sets of facets. You can have the table or the crown facets. It's the top of the gemstone that you usually look into. Then there's the bottom, the pavilion cuts, right? Okay. And each gem material the facets are cut at specific angles, critical angles, that allows light to travel in through the crown facets. And that could be either the table or the ones on the side. That light will travel down through into the gemstone, and then it will reflect back off of those pavilion facets and up out of the crown facets. And that's what gives a gemstone its bling. If you don't cut it at a critical angle, that light will go right through it, and it would be like you could read a newspaper through a gemstone. Okay, but you don't want that. You want the sparkle and the shine. So you need to make sure these are cut at specific angles. So the bottom image here is actually lifted from an interactive we have here at the museum. And I'm going to take you through this. A colleague of mine, Ben, who's a gem cutter by profession, and he's very good at what he does. And he sat through and made a recording. In this case, he's using amethyst to cut a gemstone. And this is more or less to show you the process of cutting a gemstone. And so he's first going to start by just kind of looking through maybe a window, an area you would call an area where it's really gemmy. So an area that's free of inclusions, fractures and things like that. And he might slice that up. And then he preforms that stone by just kind of getting a basic shape by grinding it down. And then he will mount that onto a dopping stick with some special wax to make sure that the stone stays in place when he goes to attach the dopping arm to the faceter. So you see he's heating up some wax with a torch and then placing it on the gemstone, which is sitting right in there, kind of a pale purple. So he's enclosing it in the wax so it will stay in place. Okay. And then I'll try to zip ahead right there. He inserts it into the arm of the machine, cuts it at a critical angle, and he'll set that. He'll adjust the angles that he needs with the machine there. And there's the grinding wheel. You'll see that once he turns it on. I'm skipping ahead a little bit. I made these videos a little too large. Yeah, and so it's just simply moving the stone back and forth. And what he'll do is he'll pivot this stone. It rotates around on that dopping arm. So he'll make a facet, rotate the stone slightly, make another facet, rotate the stone until eventually he has, in this case, he's starting with the pavilion facets, so the bottom of the stone first, and you see that he's rotated it about to create a series of facets that all meet at specific angles. Okay, and then he will flip the stone around, remove some of the wax, or remount it, the gemstone, on the dopping arm, and then begin working the crown facets. And again, the process is very similar. It's just moving back and forth. But over time, what you'll do is you'll change the grit size of the plate. So it's like sanding wood. You start with a coarser grit to get a lot of the rough stuff, and then you slowly get a finer and finer grit. And we'll do that with this until you get the final product of the polished gemstone. You'll see he's doing the crown right here. I'm just trying to be mindful of time. Just skip ahead. And so here it is. The end result is, in this case, it took just under 6 hours to do this stone, and it's an amethyst. And so this is what we're doing with tourmaline, or this is what is done with tourmaline, cut gemstones out of it. Okay, so I'll quickly try to go through this, make sure we have enough time for questions and things. So we'll finish up with some examples of tourmaline that's Maine tourmaline that's used in jewelry, and we'll go from oldest to youngest. So as I mentioned, Maine tourmaline has been faceted into gems for nearly 200 years, and they've been used in a lot of different pieces of jewelry, some more historic than others, though there are many nice new contemporary pieces. But the first necklace right here, arguably the most famous piece of Maine jewelry, is the Hamlin necklace, and it was made for Augustus Hamlin in the late 1800s, who was working at an owner of Mount Mica in Paris, and it was his father that actually discovered the location in 1820. But so it's made almost entirely of gemstones from Mount Mica, tourmaline in the center of these stones. This one here in the dead center is just under 35 carats, but it's also accented with white beryls, white to pale aquamarine beryls that surround the stones. On the left here, this pink one, it's the only one that's not from Mount Mica. It's actually from Mount Rubellite. Okay. This is a truly Maine-based necklace in the early 1900s, the Perry necklace. If you were to come to the museum now, I should note quickly that the Hamlin necklace is located at Harvard University. But if you come over right now, this one is actually on loan from the Maine State Museum, and it is on display here at the Maine Mineral and Gem Museum. And so this necklace was commissioned by Arctic explorer Admiral Robert E. Perry as a gift to his wife Josephine. And so when I say it's a real Maine-based necklace, the tourmalines, we can assume based on when they were acquired and the color of them that they are likely from Mount Apatite over in Auburn. The gold was sourced from the Swift River up near Byron, and the necklace itself was commissioned by an artist down in Portland area. So it was made of Maine material in Maine. And here's a picture of Josephine wearing the necklace there. Of course, there's the Maine State necklace. So Bethel native there, Addison Saunders, jeweler, gem cutter, he was chosen to make this necklace in celebration of a large tourmaline discovery at the Dunton Quarry in Newry. And I'll talk a little bit about that at the very end, the Dunton Quarry. And this is but I'll preface that by saying it was the largest single discovery of gem tourmaline in North America ever. And that was at the Dunton Quarry in Newry, Maine. So the center stone here it's just under 25 carats. And so the owners of that operation donated the stones and had it commissioned to be made and given to the people of Maine. If you look carefully, you'll note, again, this is all Maine gold as well, but you'll note that the settings that hold some of these stones, even around the links right there, those are actually gold nuggets. And so they used the gold nuggets from the Swift to make the settings for some of the stones in this necklace, which I think is very unique and very, very cool. Here's some of the more contemporary pieces. These are on display at the museum here. I will say, go back real quick. The Maine State Necklace is owned by, it's owned by the state of Maine. It is at the Maine State Museum. I think currently it's on display in the Blaine House, however. Yeah, so here we have some more contemporary pieces, some 3 brooches by an artist from New Mexico called Paula Crevichet. And she has on the left there, the snowflake, the top right, the wavy thistle, and then the trillium down on the bottom right. And much of this is made of Maine tourmaline, though there are some aquamarines, and the trillium is actually some garnets, which is pretty unusual for Maine, but it's all Maine stones, excuse me. Okay, so that kind of wraps it up right there. For those of you interested in learning a little bit more about Maine geology and minerals, I recommend always getting involved with a local mineral or geology club. There's one in Oxford County, the Oxford County Mineral Club. There's also the Geological Society of Maine. That's always interesting. They have annual three meetings annually, including the field-based field trips in the summer. Let's see. So yeah, so this is wrapping it up here, and I will take questions in just a second, but I just wanted to say a couple other things. So to celebrate that, the largest discovery, the largest single discovery of tourmaline in North America, and when I say largest, there's probably over a ton of gem tourmaline that was recovered from this find at the Dunton Quarry in Newry, Maine. You just think of burlap sacks filled with tourmaline, and I say that because that's what they were loading them in, with burlap sacks and other things like that, or cardboard boxes. There's just so much of it. But to celebrate this find, this is the 50th anniversary of that find, and so the museum has selected 12 different artists from around the country, and actually some outside of the country, to each create a unique piece of jewelry that will utilize a single gemstone from that discovery. And this event that we're hosting is called The Big Find, A Legend Continues. And I recommend checking out more on our website. There will be a large event in October to celebrate this, an in-person event, as well as there will be some talks among other things. But it's a really cool project that many of my colleagues here have been working on. I also highly recommend that people come, and again, I said this talk complements a temporary exhibit that will be up for one more year, but the Tourmaline Turns 200 exhibit. We also occasionally do talk series, and our research associate from Copenhagen, Denmark, Dr. Henning Hack, will be in this month, at the end of this month, and he will be giving a talk on the 27th. And this has nothing to do with Maine minerals. He might talk a little bit about minerals, but these would be minerals that are found on Mars. So Dr. Hack is a cosmochemist, a meteoriticist, and planetary scientist, and so he does a lot of work, among other things, on Mars. And so he usually would be coming annually. COVID actually put a hold on that, but he's going to be back. So he would usually give us an annual update on his research of Mars. And there will be another talk, I think, in May. Not I think, there will be another talk in May by Keith Taylor, and it will be on PFAS in Maine. So I really recommend anyone who's interested in this, learning more about this particular issue. Keith will give us a presentation on that. It will be in person, but it will be recorded as well. And so I recommend always checking out the Facebook page for more information. So that's what I have right now. I will turn my video back on, and will someone moderate the
I'll do that.
question? Okay.
Sure.
I'll check the chat and see if there's any.
Why don't you take down your screen share, and I will spotlight you and people can see you that
Okay.
way. Okay.
Hey, all right.
So now if you want, you can, we can both be here, and thank you very much for that very interesting talk. My goodness, I didn't know what I was doing as I went through those feldspar dumps when I was a kid with my little rock hammer. But now I know what I was touching on at any rate. And we were at the Bumpus Mine, which had some wonderful mine dumps when I was a kid.
Yeah, definitely.
We have one question in the chat that I saw. It said on slide 25,
Yeah.
can you estimate how long it took for these crystals to form?
Okay, and so on slide 25, I note I have the cross section of that Georgetown tourmaline. I could bring it back up if you'd like, but I could also just leave it at that. Um,
Hmm.
but how long? There are actually my colleagues here at the museum who were actually my graduate school advisors. They have done a lot of work on trying to figure out how the cooling rates of granitic pegmatites. And what they arrived at was that these crystals, even though they're very large, and there's a general rule of thumb that with igneous rocks, the larger the grain size, the longer it took to cool. But pegmatites are an exception to that rule, as they found out. And it could take days to weeks, months, and even in some cases, if it's a really large deposit, just a year or so, which is, again, um, not what most people have, even recently, would be saying in textbooks. So this is more or less recent research and kind of a paradigm shift in the geologic community. So I can't give you an estimate on how long it may have taken, but I can give you a, that's kind of a broad, days to weeks.
Thank you very much. You're welcome, all of you are welcome to put questions in the chat. You can also, at the bottom of your screen, you'll see something that says reactions. If you click on that, there's a raise hand function. And if you click on that, it puts you right up at the top corner of the screen and we will see you. And then you can unmute and ask your question. So that's another way to ask a question of Myles. So there's another question in the chat now. Are multicolored tourmalines ever found etched?
Yes, definitely. An example in Maine would be in Georgetown. So the Georgetown quarry, there's a couple of, it's a, I'm not sure if it's one pegmatite deposit, if there's a couple next to one another. My guess is that they're probably just one. But there's a couple of sites where they were mining different locations, and they're really in the stone's throw of one another. And one such location was the Harvard Cut. Is they found a series of pockets where there was blue to yellow to red to green tourmaline crystals, and the majority of them were etched,
I,
or they
I
are.
noticed
They still are etched.
I noticed that there's so many different kinds of minerals that occur in the same pockets.
Yeah.
How does that happen? What generates those kinds of things?
Well, it all comes down to the chemical composition, what you're starting with. So I said that granitic pegmatites are primarily made up of feldspar and quartz. And so what's the chemistry of these two minerals? Quartz is just silicon and oxygen. Feldspar is silicon, oxygen, aluminum. There's some potassium, sodium, sometimes some calcium in these systems. And so that's what they're taking in, and they make up the majority of the pegmatites. So if that's all they're taking in, they're pushing everything else away, right? So all
Oh,
of the interesting things, boron, lithium, fluorine, phosphorus, etc. All of these things are getting held off to the very end, where the concentration becomes high enough that you have to make something with it. And so depending on what you start with, in trace amounts, is going to result in what you end up with is a major elemental constituent that will make a mineral. And so depending on what you have in the beginning, again, that's what you're going to have in the end. And if it means that you're going to have several mineral phases in a pocket, like phosphate minerals and maybe beryl and tourmaline, well, it just comes down to the chemistry.
I see. Yeah, it's what the pegmatite rejects, so that the other minerals are somehow they're the rejection that we are valuing.
Yeah, yeah, they are, and that's like I had mentioned, the large lithium deposit that has recently been gotten a lot of publicity in Uri. You know, it has lithium minerals in there. It has very high concentration of lithium, and that's not something that you normally see. So
Thank
it
you.
had to be a melt that had a lot of lithium in it to produce these minerals.
Hmm. We have someone who's raised a hand. It's Charles and Judith Berg. If you'd like to unmute yourself, whichever of you is there, and if you want to turn on your video, that would be fine. But otherwise, just ask your question.
Okay, thank you. I wondered whether there's an experimental aspect to this. I mean, you could take a big chunk of rock and if you heat it, you might, well, if you heat it and simultaneously, oh no, I didn't want to say that. If you heat it and sequentially cool it, you could test some of the ideas that you put forth.
Yeah, Charles.
Yeah.
Yeah, absolutely right. And my colleagues do that type of work, and there's many other folks that do that. So a lot of the things that I'm talking about are not unfound. And it's not just I'm not arm waving up here. There have been experiments in a lab setting to try to confirm the observations that we see in the field. So yes,
Oh,
there can be.
good.
In some situations, but you're trying to mimic a very unique situation that's
Yeah.
naturally occurring. So you also need to take that into account. But yeah, and you're going to be doing it in a lab setting in a micro environment where these things happen on a much larger scale oftentimes. So, but yeah, I think that is something that has been done, not just in pegmatite studies. So they do that a lot in metamorphic petrology, for example, studying metamorphic rocks.
Yeah.
To try to understand which minerals may begin to occur or may begin to grow at what temperature and what pressure, which ones break down, which ones form, and so on. So yeah, there is a whole experimental petrology side of this.
Thank goodness.
Yeah.
Thanks. We have a couple of questions in the chat relating to lithium. Are there plans to mine the lithium, and is the demand for lithium driving new pegmatite mining?
Yeah, great questions. So I'll preface that by saying my colleague and I are in the process of creating an exhibit on lithium that will hopefully be rolled out next year. But I'll give you some. So are there plans to mine the lithium? I assume you mean the lithium in Maine. I have no idea. It really depends on the demand for lithium. When you think in terms of global supply chains and regional geopolitics, how that all comes into play. You need to also assess the resource, and you need to also realize that when you're like, okay, there's a deposit that's been discovered, the timing to actually get that off the ground and when it's in this case, it's a completely new deposit. It's not like this thing has been operational for decades, or it was, and then it's been dormant. That's what you call a brownfield site. And so in this case, it would probably take many, many years to get it going if you can get it going with Maine's tight metal mining regulations, because we're in this interesting situation where there was a law created to try to protect or try to prevent disasters, mining disasters from happening really in sulfide metal deposits. So where you're mining zinc or lead or copper, among other things, you have sulfide minerals, and it's those that break down through weathering processes, exposure to air, water, that create acid mine drainage, and the kind of the nightmare that you see flashing on the screens when they talk about mining, and there's yellow rivers and no vegetation in an area. That's really what those laws were used to try to created to try to prevent that from happening. But it was a blanket, all metals, even metals like lithium is a metal, but it's in a completely different mineral, in a completely different deposit that is far less reactive than any base metal deposit. So, you know, I've heard that, I've read in the recent reports that you see the lithium deposit is similar to a granite quarry, and that's true to some extent. There's just a lot more lithium mineralization in there, and the overall effects, I don't know what that is long term, though I think it's pretty benign. Lithium tends to kind of fall out into the clays as it weathers and things like that, so it doesn't get caught up in groundwater. And so I don't know if there's plans. That's kind of a long-winded way of saying I don't know if there are plans, but is the demand of lithium driving new pegmatite mining? Oh yeah, definitely. Not here in Maine, but maybe at some point. But it's driving the demand for pegmatite mining in, for example, parts of North Carolina, parts of Canada, Western Australia, definitely, where the majority of the lithium that you can get lithium from a few different types of deposits. One of them's hard rock pegmatite deposits where you're mining spodumene. The other is brines. You see down in South America, Chile, Argentina, and they're not doing any really commercially in Bolivia, but those are the more conventional lithium deposits. And it's Western Australia that has the spodumene resources that are currently being exploited down there. So.
Thank you. I think
Yeah,
maybe we have time. We maybe have time for just maybe two more questions. We have one person has raised a hand, and then we have another in the chat. Perhaps Bruce Taylor, you raised your hand. Would you like to ask a question?
Yeah, thank you. This has been a fascinating lecture. Since you were talking about mining and processes, although the associated minerals may be different from the acid mine drainage areas, the processing and beneficiation has always been a concern. And I don't know if you want to address that. Currently, other than brine, one hard rock mine, the only one that I think is up for a federal environmental impact statement, is using a tremendous amount of sulfuric acid in 2000 degrees. In fact, they have to build their own sulfuric acid plant they propose for this hard rock mining. Do you think that if they should go ahead and, like you say, it's years off if they ever go, do you think that that's how they're going to have to process, beneficiate the lithium by using sulfuric acid in high heat?
So I want to just note that you're talking about two completely different things. You're talking about mining, and then you're talking about processing those minerals, which are oftentimes done in completely different locations, though they can be done on site at the mine.
Right, I'm talking about processing that can be done on site. It may or may not be economical to take tremendous amount of raw ore somewhere else to be processing, but yeah, processing wherever they do it, on site or wherever the processing is done is I think a strong, besides noise and explosion and 24/7 processes. I think just the beneficiation of the ore, because my understanding, if it's not brine, the only way they can currently get it economically out of hard rock is by using sulfuric acid in high heat. Do you know of any other way? Because that's a real problem in areas.
To be honest with you, I'm going to pass on that one. Are there other ways? I would need to look into that. It's a good question. I do know that, yeah, in order to leach the lithium, you do have to use some type of caustic solution, and that's just a byproduct. But if the demand's there and it's economically feasible, no matter what, they'll pursue lithium deposits wherever they are. You know,
Well, thank you very much. I think we'll close with one
not trying to be
question.
ominous there about that. I'm just, that's just kind of the, you'll see in the next 20 years, at least from my understanding, that lithium mining will very much ramp up in many parts of the world. Maine we might not ever see it because of mining laws and things like that. It doesn't, there are plenty of other deposits out there. So.
Sorry, I didn't mean to interrupt you.
Oh,
I just want to, maybe we could close with a question that's in the chat and maybe extend it a little. Um, Patty Malone says, coming from Vermont, which mine or mines should one plan to visit to see the tourmalines still in their host rocks? And I'd like to ask, in general, if you might comment about mines in our area as well that might be visited and might be interesting in some way. Could you do that?
Yeah, so I will say the majority of pegmatite mines are in private hands, and so access to the property is prohibited in most cases, and the only time you can really get in is through a mineral club or some other organization that will host a field trip to the site. And so I always recommend checking out who owns the property and before going, just as a blanket statement there. But with that said, I know that I can't remember the land trust name at the top of my head, but in Greenwood, the Harvard Quarry, there's a land trust that's recently put in some trails around Patch Mountain. And so access to that quarry is, it's pretty good. And there are exposures of shoral tourmaline in that case. Yeah, across the street, down the mountain and across the street, there's the Taman and Wiseman quarry. And I know as long as the people are not mining that pegmatite, because that one is at times being actively mined, as long as people aren't mining it, you can usually go on that property. And so right there, there's also Mount Appetite State Park. And so that has a lot of the eastern pegmatite, Mount Appetite pegmatite quarries, and you can go up in there and that's free access and even dig in the dumps. But I'll just say that your chances of finding gem tourmaline are pretty low. If you were to join a mineral club like the Maine Mineralogical and Geological Society, also I call them the Portland Mineral Club. It's the largest mineral club in the state, or even Oxford County Mineral Club. They will occasionally have trips to Mount Mica in Paris, also the Havey Quarry in Poland, and it's those sites where you're a little bit more likely to find some colored tourmaline. Though I would never promise anything like that. So.
Well, thank you very much. It's been a fascinating evening, Myles, and we really appreciate your taking the time to talk to us about this. One person wrote in and said, why don't you come on down to the Hobbs Library and tell us what lovely rocks and minerals are incorporated into our fireplace wall.
Oh, yeah. Well,
so if you're down here, let us know and we'll make a list.
Excellent.
Okay, thank you very much.
Thanks.
A great pleasure, and I hope that we'll see you at the museum this summer, perhaps.
Yeah, no, it would be great if you are. Just drop me a line. I have for anyone. I have the website has my email on it, and so you can reach me there. So.
Okay. Well, thank you very much, and thank everybody for coming, and thank you to Jen Dupree, our librarian, who has managed the hosting of the behind the scenes important tech hosting of this. And I wish you a good evening.